Hi everybody, Gary Porter again. I want to show you how I'm using these. I got these E-shaped cores from Transformer. It was out of a microwave oven, and I'm making them into these pieces, and this is how I'm going to support them. I've got a couple holes I drilled through the whole pile, and I got a piece of metal that's going on the bottom here. And then when these are cut, this will go like this right here, and this will be adjustable to go to the outside of this. This is going to be about 4 inches, which is the hole in between the stator coils. So this curve right here is about 4 inches. So that's going to fit, and then I'll be able to butt these right up against the stator coils, and then just tighten these things down. And if there's a space in the middle here, I've got all kinds of pieces I'm cutting off that I can shape to help make the flux be more complete on the path. And then the different coils, so this all can be disassembled, and the different coils will go on here, shapes and sizes and wire and whatever. And the stator gets connected. This is the PC board. It's rather large. It's about 20 inches by 20 inches. And I did it that way so I could get all the circuits on one PC board. And China made them. They're about, they cost me about, let me see, I got 11 boards for 550 bucks. So they're about $50 a piece. Anyway, so you can see I've got 12 circuits here. This is for my 12 positions on the stator coils. These LEDs, this actually all matches the original Adreno board that I tested the software with, and so the Adreno is actually going to set right in here, and or this is going to be the 328 processor with a crystal, and then the connectors are out here for doing either the onboard device or using the off-board, which would be the Adreno, into the holes here. And there's a pot somewhere down here that adjusts the frequency and all that crap. That goes back up to the Adreno as well. What I did back here, I've got the connectors. On this connector, there's let me see, there's a number 1-LP, it's N, north pole, it's number 1, north, low power, north, high power, then south, low power and high power. Now the ground comes back to here on the coils, so there's only 2 connections out there. And then there's the 1, 2, 3, 4 drivers. One's for north, high power, low power, high power, low power for the south pole. And the low power connectors here for out to the 2 batteries, 12 volts for 1 battery, high power 24 volts 2 batteries. I'll start with that and see what happens. These chips in a row here are the shift registers. This is the delay chip, because what I found I needed to add over here on the prototype board, I had to add the delay in there, and only needed 1 delay, like the guy said on the internet, and that solved that problem where these ladder bits down here were kind of screwed up. So now we've also got a switch on here that it's an on and off switch, and it has to do with the delay in the software. I can either slow it way down so I can actually watch the coding coming out and watch and analyze the fields as it goes around the stator, and so that's about it. This is a 120 transformer. I've got the parts on order for the 3 power supplies, 7815, 7812, and then a 7805 for the voltages, and that's about it. So we're getting it, slow process, but this is a real bear. That's a lot. There's a lot of time in working this, and it's not easy. It's a real bear. I ended up re-drilling holes, and oh god, what a nightmare. And what I've done, I've actually wound some extra coils on the stator. I had 12 positions available with two slots, around each of my existing 12 coils. So I've got I adapted the coil winder so I can wind a bigger, that was a bigger coil I just needed to wind, so I added a piece of wood here to give the wire a little extra length to match up with what I was using. And so that's it. Anyway, have a good day.